In this video, we are going to talk about distributions, statistical distributions of data, how to test the statistical distribution of your data, and why you would want to do that. It's very important to know the distribution of your data, because that influences what statistical tests you're allowed to run on your data. Let's take an example from a recent experiment we have done. We were testing children and their ability to repeat letters or numbers. So we would present the children for a list of numbers, 9, 4, 8, 7, for instance, and they would then have to repeat 9, 4, 8, 7, and we would score them on how well they did. So in this case, some children would be expected to do well. Some children would be expected to maybe make a few mistakes, and a few children would be expected to do rather badly. So if we look at what kind of results we would expect, so this is not the real result, but what we would expect it to look like. We would expect a few children to do rather badly. Maybe one child would do only 20 words correctly out of 100. A few more would do 30 words correctly. And if we look at the other end, we would expect some children to do really well. Maybe one child would do 80 correctly, and 2 children would do 70 correctly. And then if we look at the rest, we would expect the vast majority of people to do in between. They would do average. And this is what you would expect looking at a lot of biological or medical data. Some that are very, very good, some that are very bad, and most people are kind of average. So if we then, again, still looking at a simulated data set, this is just 158 children that are simulated instead. So now we don't have room for showing small happy faces. Instead, we show how many children are in each category by the height of these columns. So if you look at the column from 50 to 60, we can see that from the height, there's 40 children that score between a 50 to 60. This is called a histogram and is a very good way of very quickly looking at the distribution of your data. So the shape of this is approximately a bell curve or a bell-shaped data set. This is also called a normal distribution or Gaussian distribution. And here we have the equation for a normal distribution. This is one of the most common distributions in natural data and biological and medical data. So there is a vast amount of statistical tests that are specialized in working with normal data. Those are called parametric tests, and they are very good at working with this kind of data. But if you try to use them on data that is not normally distributed, then they will give the wrong results. They will still run, but they will give the wrong results. So it's rather important to know beforehand whether your data is normal or not normal. So let's look still at our simulated data set. And here we have x equals, and then we have the values of what these children could score. So the first scores 52, the second scores 63, and so on and so forth. And that's the data that we have plotted over here. And it has this kind of bell shape. And if we take this data into MATLAB, then the Lilliefors test for normality is just called LiLiTest. So you write this line of code, and it'll print out h equals 0 and p equals 0.5. We won't go into the details here, but just say that when we see that h equals 0, it means that the data is distributed normally. And we can therefore use parametric tests on this data. But now let's look at the data we actually collected. So now we have decided that, well, this data analysis looked good. Let's go out and actually try to collect the data. And here is the data we collected on the children. And you can already see now that the shape of this data is very different. Instead of being distributed in a bell shape, it's all in one end, and all of it is most of the data points are close to 100. So, and remember here that they have to repeat 100 words, so they cannot get more than 100 correct. And if we then try to run the Lilliefors test on this set of data, we'll see that h equals 1 this time and p equals 0.01. And this means that the data is not distributed normally. What happened here is that the real children was doing much better than we expected in our simulated data set. So therefore, a large part of the children actually gets everything correct. And they cannot get more than 100 correct, so they're just all bunched up in one side of the histogram. This is called a ceiling effect. When you have a test where a lot of people score so well that the test cannot go any further, then you get an effect of everything being pressed up against the ceiling, as we call it, and then the data is no longer normally distributed, and we have to use a non-parametric test instead. So to summarize, biological and medical data are often normally distributed. If the data are normally distributed, we can use parametric tests. If it's not normally distributed, then we have to use non-parametric tests. We can test the data for normality with the Lilliefors test or several other tests.